All right, so pull out your sheets from last time. We had an Edgeworth box problem to work through. So consider the Edgeworth box below, which depicts the amount of soda and pizza available to two consumers, Thelma and Lou. Suppose that Thelma and Lou are initially at point A. How much soda does each have? How many slices of pizza? So go ahead and work through that. Yeah. Yeah, you could just do it on our notebook paper or something. Did you just put in another spot last time, or did you? Okay. Okay.
We did the chapters for the final.
Yeah, these were up here. Yep. Okay. What'd you get? Three and one. Okay, good. So we started off a little easy here. We got soda, and maybe I should have done some color coding here would be a better idea, but so we're at 3 and 1. So the idea of the Edgeworth box is that there's a fixed amount of output, and it opens up the idea of, well, how can they trade and make each other better off? So suppose that, part B, suppose that Thelma and Lou's child Ted takes 2 pieces of pizza from Lou and gives them to Thelma, then takes 2 sodas from Thelma and gives them to Lou. Find and plot the new allocation in the Edgeworth box. Label the allocation with a large B. Does such a reallocation represent a Pareto improvement? From utility, it'd be on a lower indifference curve, right? So the indifference curve shows us all points of indifference. So I don't care if I'm at A, B, or C. I maintain the same level of utility equal to 100 units of satisfaction no matter where I'm at. And so in order to get on a higher indifference curve, the axioms of preference tell me that I'd have to move from point A somewhere in this direction to be assured that I'm going to be better off, and which would put you on a higher indifference curve.
So it is, since it's on the same indifference curve.
So that's getting to what's our answer for B? No. So in order to be in a Pareto improvement, what has to happen? At least one person has to be better off. We don't have to make both better off, but we have to make at least one person better off. So at point B, we've got both parties at the same indifference curve. So no Pareto improvement occurred. All right, so now there's no Pareto improvement. Does that mean that B and A are Pareto efficient? No. Why? What does it mean to be Pareto efficient? It's just a little twist on that definition. Yes, there's a reallocation that can make somebody better off without making anyone else worse off. So a Pareto efficient point is one that we can't make anyone else better off without making somebody else worse off. And as Sam was saying, the football region gives us all a whole bunch of points where we can make one or both better off. So C. Suppose that Ted had reallocated one piece of pizza and one soda instead of two of each. Would such a reallocation represent a Pareto improvement? Explain your answers. So what if we went 1 and 1? Yeah, right? So that ends up putting us on a point C here at 2 and 2. And that means both parties are made better off. So we definitely have a Pareto improvement. This goes a little bit beyond what was being asked. In order for this point to be Pareto efficient, the necessary requirement would be that the two indifference curves are kissing at that point. Otherwise, there'd be a football region, right? Probably, yes. But we don't know that they're nicely, parallel shifts of it. But yeah, the way they set up this one, it's likely that that could be, but we don't know for sure. So the question doesn't even go that direction. So that's why I'm pointing it out. It would need to be that because it's possible to, if the preferences moved a little bit, we still could have, let me just, if the red curve looked like that, then we still have room for improvement, right? Okay. And so what's happening when both those are tangent? What's the condition? It's Pareto efficient, but mathematically, back from the utility chapter, marginal rate of substitutions are equal to each other. So for both parties, the marginal rates of substitution are equal to each other. Okay. So what makes this general equilibrium theory is we're going to use that same logic and apply it to producers under the situation of scarcity of resources. So we've got labor and capital for I guess we could say, give me a good, any good. Output, any good. First thing that comes to mind. Go. What? Popcorn. And we've got another good, somebody other than Cadence. Cats? Okay, this could get interesting. I like it. All right. So our two outputs are popcorn and cats, and we learned from our production chapter that we can use various combinations of labor and capital to produce popcorn, right? And we had a curve that looked like this also. What was that curve called? The isoquant. So we had an isoquant here where the production of popcorn was equal to 100 bags at all points along here. It showed various combinations of labor and capital that could be used to produce that level of popcorn. On the cat side, we also have an isoquant that shows that along this isoquant, 40 cats can be used, and it doesn't matter. We could have a capital-intensive production of cats, so apparently we're doing sperm injections or something. We're using a machine to do the job for us. Or we do it the good old-fashioned way with a labor-intensive method where we just let a couple cats go for it, right? So do we use a capital-intensive method or do we use a labor-intensive method? So along that isoquant, we get the same thing. So use your imagination now. Take this one, flip it over to this one. We're going to have the same thing going on in the Edgeworth box with a scarce amount of resources in the form of labor and capital. we can think about the choices that society must make. So if we've got popcorn labor going this way, so we've got, let's stick with popcorn down here. We'll put our cats over here. So we're going to have labor increasing with popcorn this way, capital increasing that way. With cats, we've got, I'll go back to a different color here, we'll go orange. We've got capital increasing that way with cats. And now we start to see that there's choices of what we're going to produce in the economy. And so if we're at a cat isoquant like this, and we're at a popcorn isoquant like this, let you guys catch up. Yep, so those arrows are, yep, we're increasing. And what we're doing is we're increasing those inputs for cat production. So those inputs going this way are being used for cat production. Popcorn going this way. But it really highlights the idea of scarcity for us. So we got a football region, so if the economy's currently at point A, what can be done? What's possible to be done if the economy's currently at point A, John? A Pareto improvement, right? So we can reallocate resources somehow and get more of both potentially, right? Or more cats. So if we got, let's just think about 3 points here, B, D, and E. All three of these points represent Pareto improving points. On point B, we don't get any more cats. We still only have the quantity of cats equal to 40. And for isoquants at point E, if we have still popcorn sitting at 100 units, point B says we can have more popcorn and the same amount of cats. Point E says we could have more cats and the same amount of popcorn. Point D says we could have more of both. Right? So anywhere in the football region represents a Pareto improvement compared to point A. Now, similar to what we saw in this problem, this point would be no Pareto improvement. Okay, so maybe for this diagram we'll just put point B here. So point B, we have more popcorn and same cats. Point E, we got more cats and same popcorn. And at point D, we got more of both. And the key is that all of these are Pareto improvements to point A. All Pareto improvements to point A.
So then what, if it's like before point A, like on the outside of the football?
Yeah.
There's like a point over there, then that's when it would be the same for popcorn, but it'd be worse off for cats.
If it was on one of them, it would be the same for popcorn. So this point would be the same for popcorn, but less cats, right? But this point would be less of cats and more of popcorn. Okay? So we'd be trading them that way. All right, so how does this fit into the good old-fashioned production possibilities frontier, where now we measure popcorn and cats? Production possibilities frontier shows the maximum combination of two goods the economy can produce given its available resources and technology. So, where is point A on this graph? Inside, right? So the production possibility frontier shows the maximum points. So our point A in this space, on output space, popcorn and cats, we're inside the frontier, which is inefficient, right? So all these things are kind of marrying up now in different ways. That's part of the reason it was inefficient. There was other ways to combine labor and capital using better technology, for instance, to be on the edge somewhere.
So which point do you fall on the edge, or do you not know until you know where they're tangent?
We went, if these are points of tangency, so maybe we'd, if you guys want to add this, put a dash line and a dash line, because I do want to head that direction. So let's say they were tangent points at B and E. Then let me put 3 points here. Hypothetically, which one's B and which one's E? I'll give you a hint. The middle one's D for sure. Which one's B? Which one's E? B is up, and E is down. So that's how this concept ties into our production possibilities frontier. The first lesson in Principles 101, the production possibilities frontier, comes right back to this. Now, back to the isoquants a second then. With the contract curve, we can think of these being all efficient points. There being some set of points that represent technological or production efficiency. Right? So this was similar to the contract curve. And at all these optimal points, the slope of the isoquants are equal, which means what? What was the slope of the isoquants equal to? Now we're pushing you a little bit, aren't we? So it was yes, we had the wage over the rental rate was our optimal condition, but that wasn't the slope of the wage constraint was the straight line we had, our cost constraint. Yeah, marginal rate of, what was it? Whether it was slightly, we had marginal rate of substitution for utility functions, marginal rate of technical substitution. Good. So marginal rate of technical substitution of labor for capital equals, no, but what is it in detail? How did we solve that? Marginal product of labor over the marginal product of capital. So it was the ratio of the marginal products. Marginal product in its raw form is the change in quantity over the change in labor over the change in quantity from a unit change in capital. Right? If we break it down to all its raw components, that's where we're getting slopes from here. Remember, we're measuring L and K. So along the contract curve, we're getting that optimal condition satisfied between the two firms now. So the marginal rates of technical substitution between the two companies are optimal and equal. Okay.
Point D? Or
Any of these points along the contract curve. Yes. So kind of the key result here is that at points B, D, and E, the marginal rate of technical substitution for cats is equal to the marginal rate of technical substitution for popcorn. And this is between labor and capital for cats, labor and capital for popcorn. Michael, was that a minus point? Okay. So our last condition we want to think about is we've got people who enjoy popcorn and cats, right? And so all points along the production possibilities frontier are productively efficient, but what was the thing that we got in the marketplace? What type of efficiency we've talked about many times? Allocative efficiency, where the marginal benefit equal the marginal cost. And so our last point to this is that society might have an indifference curve between cats and popcorn that looks some way. We have some sort of preference shape, and we get happier the more and more we consume. If we're at this combination, point B, if we're at point B or point E on an indifference curve, society could be made better off by being at point D. And so our over-the-top kind of condition is this one. Our final welfare condition is having an indifference curve now that's at the highest point. So the optimal point for society has all of these conditions overlapping each other. The marginal rate of substitution for consumers between cats and kittens. Wait, I had some popcorn. I went to cats and kittens. Got me going on kitties now. Cats and popcorn equals the marginal rate of technical substitution. And this is called now the marginal rate of transformation. Marginal rate of transformation. How does society optimally transform one output into the other? The marginal rate of technical substitution dealt with labor and capital substitution, the inputs. We're going to convert that just the way we did in Principles 101. Moving from point A to point B, we have to give up this many to get this many. That's the marginal rate of transformation. And so those two things need to be equal in equilibrium.
The subscripts on marginal rate of transformation.
Yes. All right, that wraps up general equilibrium.